While it may give rise to some confusion, it's a good thing to have an understanding of where the modes, the so-called modes, come from and why they are called modes, as it can help you rationalize in certain situations. But if this video makes you confused, bear in mind that the most important information you have about a scale is its interval code that we have been discussing. So what we've done so far, we started out by deriving this code here, which is the code for the Ionian mode, or what we more popularly say, the major scale. And we found this code by measuring the distances from the root note, the one note, to each of the other notes, like that. And we found out that in this particular case, we got only major and perfect intervals, as it said, which is a definition of the code of the major scale. What if we do this analysis from another note in the same scale? Let's say we do the same analysis beginning on the second note. So we remove the Roman numbers and we go to the second note and we add the Roman numbers from the second note. And so, as you might remember, as I said, this particular code implies that this only major and perfect intervals, that is, it should be a major second, a major third, a perfect fourth, a perfect fifth, a major sixth, and a major seventh. So we now need to verify whether this is the case. So we move from this note to this note, and we find that 1, 2, that is indeed a major second, 2 half steps. We move from here to here, and we find 1, 2, 3, which is not a major third, it's a minor third. So we need to reflect that in the code. So we continue with the fourth, which should be a perfect fourth. And it's 1, 2, 3, 4, 5, which is the definition of a perfect fourth. We go to the fifth, and we should find 7 half step. 1, 2, 3, 4, 5, 6, 7, which is what we do. We go to the sixth, and this should be a major sixth, which should be 9 steps. And we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, that is also correct. And the last, the seventh, which according to the code should be a major seventh, which is 11 half steps. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that one needs to be adjusted. So we adjust that one. So, and what you see here is the code for the Dorian scale that we have. So we say that the Dorian scale is the second mode of the major scale, since it's simply the code occurs on the if we analyze from the second step of the major scale. So thereby Dorian mode is the second mode of the major scale. And we may then continue. We want to start on the third step, so we start here, and we will then get this, which you will find is the code for the Phrygian scale. So the Phrygian scale is the third mode of the major scale. And we can then go on to the fourth, fifth, sixth, and seventh step, and we will get new scales. And I can tell you that on the fourth step, you will get the Lydian scale. And on the fifth step, you will get the Mixolydian scale. And then you will get on the sixth step, you will get the Aeolian mode. And on the seventh step, you will get a scale that we haven't discussed. It's called the Locrian mode, which by all means is one of the modes. There are 7 modes. However, I have excluded it because it's much less used than the other 6. And also it lacks some musical properties that makes it significantly less musically usable than the other ones. And therefore, so I think it's most important to know the 3 the three major scales and the 3 minor scales. And that is the origin of the modes. And an important consequence of this is that when it comes to that can help you rationalize, as you see, you will have 7 different interval codes per scale, and they will all have the same key signature. So what we can say that you will have the same key signature for C major as you will have for the D Dorian, the E Phrygian, the F Lydian, the G Mixolydian, the A Aeolian, and the B Locrian. They will all have the same key signature, which can, as I said, be a very, very convenient rationalization to make.